Hey, I'm Kilian, co-founder of N2 Photonics. In this video I will introduce the integrating sphere as a useful tool to couple your laser light into an optical spectrometer. The integrating sphere is a simple hollow sphere made from a scattering material. The sphere has two openings, a large entrance opening and a small SMA fiber port on top. Now let's compare the integrating sphere to four coupling methods. Laser light directly into the optical fiber, scattered light from a matte surface, a cosine corrector attached to an optical fiber, and a poor man's cosine corrector, also known as sticky tape. In all these examples you can see that the measurement is sensitive to various degrees to the alignment of the optical fiber. In comparison, the integrating sphere can be translated and rotated quite a bit before introducing a meaningful difference in the measurement. It has some distinct advantages. The random nature of the coupling makes it insensitive to the alignment. As long as the beam enters the sphere, there will be some power coupled to the optical fiber. Additionally, no interference can occur in the optical fiber between the integrating sphere and the spectrometer, since the coherence is lost inside of the integrating sphere. Of course, there are also drawbacks. Firstly, the coupling efficiency is rather poor, typically on the order of 0.1%. However, when you're working with high-power lasers, this should not be an issue. Secondly, the integrating sphere averages the spectrum over the full beam, and it therefore masks any spatio-spectral inhomogeneities. That's why we think integrating spheres are a useful tool. And at N2 Photonics we give them away at our trade show booth. So come and visit us at the next show.